Hello everyone, this is Mr. Appel, and today I'm going to show you how to convert absolute value functions to piecewise functions. So let's start by remembering what the definition of absolute value is. The definition of absolute value, or one way of looking at absolute value, is if the absolute value of the number that you're taking is positive, you just get that. So if this thing is positive, then you just get that. So for example, if you plugged in 8, you would get, let's just erase that. If you plugged in 8, right, you would get 8 minus 5, you'd get absolute value 3, which is just 3. But if you plugged in, let's say, 2, you'd get the absolute value of 2 minus 5, which would be negative 3, which would be the opposite of negative 3. So when the number inside the absolute value goes negative, you get the opposite of whatever it is you started with, right? So that's what happens. So in terms of algebra, algebraically speaking, if this expression is positive, or I should say if it's non-negative, then you just get whatever x minus 5 is. But if whatever is in here is going to be negative, then you get the opposite of whatever x minus 5 is. Okay. So in terms of a piecewise function, we need to find the place where it changes. So I need to know, when is this thing non-negative? Well, that's easy to do. I just write a simple inequality. When is that expression non-negative? And then solve it. Okay, so now I know, based on this, that when x is bigger than or equal to 5, this function is non-negative. And that means that when x is less than 5, it is negative. So our piecewise function, if we're going to convert that now into a piecewise function, okay, we're going to say that the value of this thing is it's x minus 5 when x is bigger than or equal to 5, but it's the opposite of x minus 5, or negative x plus 5, when x is less than 5. So again, when what's inside the absolute value, when that is negative, we get the opposite of the result. When it's non-negative, we just get whatever that number is. So that's how you would convert to a piecewise function. Now we're going to step it up a notch and look at another example. So here's an example where we have two absolute values in the function. So now things get a little wacky. So let's start by determining when each of these things is non-negative. So we know x minus 5 is non-negative when x is greater than or equal to 5. Similarly, we can determine that x plus 3 is non-negative when x is greater than or equal to negative 3. So there's really three regions here. What I'm going to do is I'm going to start to build my piecewise function based on these ranges. So if I'm thinking of where is my range, so there's stuff happening down here below negative 3. So there's something happening when x is less than negative 3. There's stuff happening between negative 3 and 5. So when negative 3 is less than or equal to x less than or equal to 5, there's something happening. And then when x is greater than 5, something is happening. Okay, so let's see what that something is. Well, when x is less than negative 3, so when x is less than negative 3, this expression is negative, and this expression is also negative, right? I mean, just think of an example. If I picked, let's say, negative 4 is a number down here. Negative 4 minus 5, that's negative 9. So I wouldn't get what x minus 5 gives me. I'd get the opposite of x minus 5. Plus, if I plug that same, what number did I say, negative 4, if I plug negative 4 in for x also here, this would also be negative, so I'd have the opposite of x plus 3. Sorry, I'm running out of space there. So if I simplify this expression, watch what happens. I have negative x plus 5 minus x minus 3, which simplifies to negative 2x plus 2. So just kind of cleaning that mess up a little bit, and you might kind of go off to the side to do that work. Usually a good idea. Okay. What I have is when x is less than -3, in other words, when both of these are negative, the value of this function is -2x plus 2. Kind of cool. Now, in between, so when you get numbers between -3 and 5, this one is positive, because numbers bigger than or equal to -3 make this expression here positive. But this one is still going to be negative, because I need numbers bigger than 5 to make this positive. Okay, so if this expression is positive, but this one's negative, I'm going to get this. I'm going to get -x plus 5, because it's the opposite of that expression, plus this one stays the same because that one's positive. Now watch what happens when I simplify this. -x plus x cancels out, and I just get 8. I actually get a constant. So no matter what happens, if you plug in a number between -3 and 5, you get 8. If you don't believe it, try it. Pick a number. Let's say I pick x equals 2. 2 minus 5 is -3. 2 plus 3 is 5. So we have absolute value of 3 plus absolute value of 5, which is 3 plus 5, which is 8. And that will work for any number in that range. So the value of this function between those two is simply 8. Kind of unexpected, but kind of cool. Okay, now over here, when x is bigger than 5, both of these are non-negative. So we simply get x minus 5 plus x plus 3, which is 2x minus 2. And so that's the value of this function there. And so we now have a piecewise function that is equivalent to our absolute value function. And so if we wanted to graph that, I'm going to see if I can make this fit. Whoopsie. Okay, so if we can make that fit a little bit. I want to see what that looks like on a graph. I should have planned a little better for this, but that's okay. I'm just going to roll with it. Do a little trickeration there. Oops, okay, sorry, it's getting small. You might have a little trouble seeing it, but hopefully you'll still get the gist of it. So when x is less than -3, so down here, it's -2x plus 2. So the graph -2x plus 2, you can just plug in some x values. So let's say I plug in -4. So when x is -4, -2 times -4 is 8. 8 plus 2 is 10. So -4, 10 would be here. -3, so -2 times -3 is positive 6, plus 2 is 8. So that's going to be right there. Okay, so going out that way, that thing goes up like that. Now remember, between -3 and 5, it's actually equal to 8, so it's just a straight line across till I get to 5. Now when x is bigger than 5, it becomes 2x minus 2. So you could even use what you know about slope and just go up 2 and over 1 and up 2 and over 1 and up 2 and over 1, or you could put in a couple more values to get your graph, and then you see what your graph is going to look like. Sorry that got a little bit messy, but hopefully you get the point. All right, that's all for now. Thanks.